Did you know that the universe's most profound secrets are hidden in the tiniest of leaps? Imagine an electron in an atom. It's not just orbiting like a planet around the sun. Instead, it exists in specific energy levels, like steps on a staircase. These steps are not infinitely close together. There are distinct gaps between them. Now picture the electron suddenly jumping from one step to another, without ever crossing the space in between. That's a quantum leap. These leaps might seem small, happening at the subatomic level, but they hold the key to understanding the universe's most profound secrets. Quantum leaps are not just about electrons in atoms. They govern the behavior of light, the interactions of particles, and the very fabric of reality. Quantum physics often baffles many due to its counterintuitive nature. One common misconception is that particles like electrons move in smooth, predictable paths. In reality, their behavior is probabilistic and can seem random. Another misconception is that quantum leaps are gradual transitions. They are actually abrupt, discrete changes in a quantum system's state. This sudden jump can be confusing because it defies our everyday experiences. Understanding quantum physics requires letting go of classical intuition. It's a challenge, but it opens up a fascinating world of possibilities. Quantum physics often gets a bad rap for being too weird, too complicated, too detached from reality. But while it challenges our everyday intuition, it's not as esoteric as it seems. One common misconception is that quantum physics is just theoretical, with no practical applications. Nothing could be further from the truth. Quantum physics underpins many technologies we rely on, from lasers and transistors to medical imaging and nuclear energy. Take quantum entanglement, for example. This phenomenon occurs when particles become interconnected, such that the state of one instantly influences the state of another, regardless of distance. Or consider superposition, where particles exist in multiple states at once until observed. These concepts defy traditional physics, but are fundamental to quantum mechanics. And the more we explore the quantum realm, the more we realize its profound implications for our understanding of the universe. Quantum weirdness. Quantum leaps are just the tip of the iceberg when it comes to the strangeness of the quantum world. Two phenomena, in particular, entanglement and superposition, highlight how quantum mechanics supports theory, but with deeper mathematical precision and experimental evidence. Defying our analogies to simplify quantum concepts. Quantum entanglement is a phenomenon in quantum mechanics, bizarre connection between two or more particles, where they become linked, even if separated by vast distances. Imagine you and a friend each have a magic coin that is mysteriously linked. You take one to the moon, and your friend takes the other to Mars. When you flip your coin, it can land on heads or tails. But the moment you check, your friend's coin instantly shows the same result. No matter how far apart you are. Even stranger, before you look, neither coin is definitively heads or tails. They exist in a mixed state of both at once, until observed. This bizarre, instant connection is called quantum entanglement, one of the strangest phenomena in physics. That's the essence of entanglement. Superposition is even weirder. It suggests that a particle doesn't exist in a single state until measured. Instead, it exists in all possible states simultaneously. Think of a coin spinning in the air, neither heads nor tails, until it lands. That's superposition. These mind-bending concepts might seem like science fiction, but they are supported by countless experiments. They demonstrate that the quantum world operates by rules radically different from our classical experience. The implications for technology and philosophy are profound, potentially revolutionizing our understanding of reality itself. Leaping into the future. Quantum leaps are not just theoretical curiosities. They have the potential to revolutionize technology and reshape our philosophical understanding of the universe. Quantum computing, for example, harnesses the power of superposition and entanglement to perform calculations that would take classical computers billions of years. This could lead to breakthroughs in medicine, materials science, artificial intelligence, and countless other fields. Quantum cryptography promises unhackable communication, exploiting the bizarre properties of entanglement to create secret keys that are impossible to intercept. And quantum sensing allows us to measure physical quantities with unprecedented precision. Beyond technology, quantum leaps force us to confront profound philosophical questions. If the universe is fundamentally probabilistic, what does that say about free will? If entanglement connects everything, how do we understand individuality? These are just some of the questions that quantum mechanics compels us to ponder. So, what quantum concept amazed you the most? Share your thoughts in the comments below, and don't forget to like and subscribe.